Alrighty, let's do it. One more blurb about nomenclature, and we'll be good for a little while, I hope. Um, this one, we're going to cover two things, oxo acids and hydrates. And um, yeah, let's just dive right into it. We talked, there we go. Okay, we talked about acids before. Remember, they're going to dissolve in water and produce hydrogen ions in water. Uh, You can pick out the acids because the H is written first. We talked about binary acids, it's hydrogen and one other thing. Um, with the oxo acid, it's hydrogen and an oxo anion. Okay. These, if you remember, are polyatomics. Okay. So in a for these guys, you should be able to recognize that polyatomic. So there are going to be other things in there. The name of these acids are going to be based off of what the name of the polyatomic ion is. So it's clearly crucial that we're going to need to know those things. Okay. Our rule is this: if your anion is an AT anion, then we're going to convert it to ic and just call it whatever ic acid, right? So all of these are based off of the anions. Okay, so it's going to be whatever ic acid if you start with AT, end with ATE. If you end with ITE, then it's going to be something us acid. Notice there's no hydro here. Hydro is just for binary ones. Okay, so yeah, ate becomes ic, ite becomes us. You throw the word acid on the end and you're great. Okay. Now, there's a cheesy saying, and I put it down here just so we can kind of remember it. I learned this in high school, and the older I've gotten, the less I'm sure if this was true or not. But at the time in high school, I totally believe this was true. Our high school teacher talked to us about her trying to get her little son, to eat Brussels sprouts, and he didn't want to. But he looked at her and he just goes, "But Mama, I ate it already, and it was icky." Whether or not that's true, I don't know, but I use it all the time, right? I ate it already and it was icky. So the ATE becomes the ic acid. Okay. That's how I remember it. You can laugh at me, whatever you want to do. It's fine. If it helps, fine. If it doesn't help, don't worry about it. So, for example, if we had this acid, HNO3, NO3 minus is nitrate. That ends with ATE. So this is nitric acid. All right. If we had HClO2, that looks like CO2. There's an L in there somewhere. There we go. That, I'd never fix it. HClO2. That's better. All right. If we have HClO2, ClO2 is chlorite. That's ITE. ITE has to be us. So this is chlor us acid. Okay. Not too bad. If we have H2SO4, SO4 is sulfate. So this becomes sulfuric acid. Okay. This is also an example of something called a polyprotic acid. Okay. So most of the acids we see are monoprotic, which means they have one hydrogen, one ionizable hydrogen, we'll say that. Polyprotics have more than one ionizable hydrogen. So sulfuric acid is a diprotic acid because there's two ionizable hydrogens in the front, right? If we had phosphoric acid, which is H3PO4, phosphoric because it's from phosphate. This is a triprotic acid because there's three ionizable hydrogens in the front. Okay. One thing I'll point out here is acetic acid and other acids sort of like it also have other hydrogens in it. This is why I write acetic acid this way, HC2H3O2. This is the acetate polyatomic ion. This is the acidic hydrogen in the front. That's a monoprotic acid. Okay. You might also see it as CH3CO2H or CH3COOH. In this case, it's written kind of in a more organic nomenclature kind of way, and it's the H here on the end is the acidic hydrogen. Okay, but this is all acetic acid. Okay. Um, you can actually turn every polyatomic ion into an oxo acid by adding enough H's in the front of it to make it into a neutral compound. So if I gave us, it doesn't even have to really be an acid, ion that we know, but say we had AsO4, 3 minus, okay? And I'm going to tell you this is called arsenate. Uh, it follows the same pattern as phosphate, but because it's arsenic, it's arsenate. Um, we have a 3 minus. That means we can make an acid that's H3AsO4. So then now this is arsenic acid. Okay. So a good way to practice doing your acids is to just look at your list of polyatomic ions, put H's in the front of them until they're neutral, and then name them that way. Okay. ATE becomes ick, ITE becomes us. All right. The other thing that's in this, and these are linked together because these topics are linked together because all of these things are combinations of things that have covalent bonds and ionic bonds. And I haven't stressed about it too terribly much, but there we go. All right, let's talk about hydrates. A hydrate happens all the time. Hydrates are some sort of compound that has water bound in its crystal. Okay. The key here is the water is bound in the crystal. The water is part of the compound itself. Okay. It's in a specific ratio with the compound, um, and the water becomes part of the formula, right? So here we have copper 2 sulfate. So we have a copper 2 plus, we have a sulfate, and then there's water stuck to it. So in the hydrate form, the water is stuck to it. Okay. Something to remember here, if it's anhydrous, it means without water. So here we have anhydrous cobalt 2 chloride, and here we have cobalt 2 chloride as a hydrate. They're two different ideas, right? The color is different, the the formula is different. There's no water there. The same thing up here, right? This is the anhydrous form and this is the hydrate form. Okay. When we're naming the hydrate, it's exactly the same. We're naming it as the ionic compound, but we have to put something in there to tell us what how many hydrogens, how many waters are there. So here, I'm going to write this again so it's bigger. We have COCl2 dot 6H2O. So this tells us we have one COCl2, cobalt 2 chloride formula unit, and that there are 6 water molecules bound in the crystal. Okay. When we name this, we're going to use the name the same way we had before, cobalt 2 chloride. And then we're going to say hydrate, and we're going to put a prefix on it to tell us how many waters are there. These are the same prefixes we saw when we named molecular stuff, right? So we have 6 waters there. So this is hexahydrate. I know my handwriting is garbage, but this is 3 words: cobalt 2 chloride hexahydrate. Okay. I'm going to throw this other prefix at you that's not in the table because this happens very well occasionally, I should say, is hemi, and hemi is the prefix for a half. Okay. Um, and this happens just because we're talking about how many water molecules are there for every one formula unit. And there are some things where there's 2 formula units for 1 water molecule, in which case that would be a half. And we'll see those examples in a second here. Okay. So let's work some stuff out. Again, I'm just going to name some stuff and look at some formulas as we go. We just talked about hemi, so let's do this. CaSO4 dot 1/2 H2O. Okay. So hopefully we remember from before that this is calcium sulfate. Okay. The half is hemi, and there's a hydrate. Okay. If we have, say, this, I just did that. Here we go. LiCl dot H2O. Okay. We know it's a hydrate. We have LiCl. This is lithium chloride. Lithium doesn't have options, so we don't need parentheses. Okay. We have hydrate. We have one hydrate molecule here, so this is going to be monohydrate. Cool. We should be able to do this the other way around, forwards, backwards. So if I give you a formula, you can figure out the name, or that's what we just did. If I give you a name, we should be able to figure out the formula. Let's say we have manganese 2 sulfate hexahydrate. Okay. Okay, we're gonna have to figure out these ions as we're in here. Manganese 2, this tells us Mn2 plus. Sulfate, if we remember, is SO4, 2 minus. Okay, that's not too terrible. So this is MnSO4. Okay, oops, 4 dot hexahydrate. Hexa means 6, hydrate means water, so 6 waters. Okay, let's do one more and then we'll call it a day here. Strontium nitrate tetrahydrate. There we go. Okay, strontium nitrate tetrahydrate. We're gonna do the same thing we did over here. Strontium. You could remember that strontium is in group 2, which is always 2 plus, or that nitrate is NO3 minus. Okay, that all works out. Now, because we have a 2 and a 1, we can have strontium NO3 2 tetrahydrate. Do we know what tetra means? Okay, right. Tetra's 4. Hydrate. Okay. Not too terrible. Our focus here is naming stuff. I want us to remember that how we name the acids, right? Ate becomes ick and ite becomes us. And then when we're talking about hydrates, we need to be able to know them. So the prefixes, there's that new hemi prefix. And I want us to know the difference between a hydrate and an anhydrous. Okay. Um, sounds good. I will catch you later. Let me know if you need anything. I am here.